Today, we're diving into a really big question in AI. What if we've been teaching machines to learn all wrong? There's a new approach, and it's inspired by our own brains. It suggests the real secret to intelligence isn't just about crunching data, it's about learning by doing.
To really get this, let's just step back and think about something simple. How does a baby learn what a cup is? I mean, they don't just sit there and look at millions of pictures of cups, right? Of course not. No, they interact with it. They pick it up, they turn it over, maybe they even drop it a few times. They're feeling its weight, its curve, where the handle is. This is something called sensorimotor learning. The brain is literally building a model of the world through physical touch and movement. It's totally active, not passive at all.
And this really highlights a huge difference between us and most of the big AI models out there today. We learn actively, building these rich, 3D models of things based on their shape. But AI, it learns passively, just by analyzing flat 2D images. And this leads to this really weird problem called texture bias. An AI might see a picture of a cat printed on the side of a mug and get confused, because it's way more focused on the furry texture than the actual 3D shape of the mug.
Okay, so if current AI is missing this huge piece of the puzzle, where do we look for a better way? Well, the answer might be right inside our own skulls. Researchers are looking at the brain's actual blueprint to try and build a completely new kind of AI. And this whole idea is built on something called the 1,000 brains theory. The big idea here is that your neocortex, the wrinkly part of your brain, isn't one giant supercomputer. It's more like a massive committee of thousands of tiny, independent mini-brains. Each one of these, called a cortical column, is learning its own model of the world by linking what it senses to how it moves.
So how does one of these little mini-brains actually learn what an object is? It's kind of like a 4-step dance. First, a sensor, think of your fingertip, touches one little spot on the object. Second, you move. Third, your fingertip senses a new spot. And fourth, this is where the magic happens. The brain connects those two feelings, using your movement to place them in a 3D mental map. It's building a structured model of the object's shape piece by piece.
Which finally brings us to Monty. Monty is the first AI system built from the ground up on these exact brain-like principles. It's an AI that doesn't just look at data, it actually explores its world. And fun fact, it's named after Vernon Mountcastle, the neuroscientist who first discovered these cortical columns.
So what makes Monty so special? Well, it learns through that active interaction we talked about, building real 3D models. That means it can focus on shape, not just texture. And it uses these super efficient local learning rules. Basically, when different parts of the model fire together, they wire together. This lets it learn new things all the time without, and this is huge, without wiping its memory of the old things. And we're going to see just how important that is in a minute.
You know, a great theory is one thing, but you've got to prove it works. So the researchers put Monty head-to-head against some standard, powerful AI models in a series of challenges. This was all about testing the real-world fundamentals of intelligence. First challenge up, data efficiency. We all know that modern AI is incredibly data-hungry. It can take millions, even billions of examples to train them. So the question was, how would Monty do with just a tiny, tiny fraction of that data?
The results are pretty wild. After seeing each object from just 8 different angles, Monty hit 88% accuracy. A standard AI model, a vision transformer, when trained from scratch on the same tiny dataset, it only got to about 30%. Now, a massive version that was pre-trained on 14 million images did a little better, sure, but think about it. Monty got almost the same result with just a microscopic amount of the data. All right, the next test targets one of the most famous and most frustrating flaws in AI. It's called catastrophic forgetting, and yeah, it's pretty much as bad as it sounds. It's when you teach an AI something new, and in the process, it completely and suddenly forgets everything it learned before.
So the experiment was beautifully simple. They were going to teach the AIs to recognize 77 different household objects, but here's the catch. They had to learn them one at a time. So first you learn what a mug is, then you learn what a bowl is, then a drill, and so on, one after the other.
And here is the million-dollar question. After the AI finally learns to identify object number 77, does it have any clue what object number 1 was?
This chart just says it all. Monty, it remembered everything. The first object, the 40th object, and of course the last one. The standard AI, total failure. It only remembered the very last thing it learned. Its knowledge of that first object was completely gone.
And that's because Monty's learning is local. It only updates the one little mini-brain that's relevant, while the traditional AI has to update its entire network, basically overriding all that old knowledge.
Okay, on to the final test. And honestly, this one might be the most staggering of them all. Training efficiency. We're talking about raw computing power. How many calculations, or flops, does it take for these systems to actually learn? Okay, just get ready for this number. To get to a similar level of accuracy, Monty required 528 million times fewer computations than the big pre-trained AI. Let me say that again, 528 million times less work. That's not a typo. We are talking about a fundamental, game-changing difference in efficiency.
So, what do we make of all this? We've seen an AI that can learn with way less data, learn without forgetting, and learn using a tiny fraction of the energy. I mean, could this be a whole new path forward for artificial intelligence?
The researchers behind Monty definitely think so. They say their findings show that these 1,000-brain systems are a really powerful and promising new direction for AI. And it just reinforces how absolutely critical that idea of sensorimotor learning by doing, really is.
And let's be really clear here. This isn't just about making an AI that's a little bit better at telling a mug from a bowl. What we're really looking at is a potential blueprint for a totally different kind of intelligence, one that's way more efficient, way more robust, and more grounded in the real, physical world, just like ours.
Which really leaves us with one last massive question to chew on. If an AI can truly learn the way we do, could it one day reason the way we do?